Out to Aaron, to Hattie, to Louise, to Emma, Piranha. Okay. All right. So here we go. Chain rule. Just to be clear, I'm going to change this problem. I'm going to change this problem to the following: 2x minus 3 to the 400th power. Just to, again, put us back into that moment, you want to find the derivative of that. Could you imagine multiplying that out 400 times?
No.
I mean, that would be absolutely absurd, wouldn't it?
Absolutely.
And so we said that the chain rule is nice and easy. All you have to do is divide up into 4 boxes. We list the inside function. What's the inside function? 2x minus 3. What's the outside function? U to the 400th power. What's the derivative of 2x minus 3?
2.
What's the derivative of u to the 400th? So our final answer is those two multiply together. And you can see you get f prime of x is equal to 800 times 2x minus 3 raised to the 399th power. Not too bad, huh? Let's skip number 2. We don't need to do it. We move on to number 3. Okay, this came up from Miss Hannah. She had a question about this one because she saw the negative 4 out front. Never mind the negative 4. We got a 5x squared. Negative 4 is just a multiplier. We got negative 4 secant of u. What's the derivative of 5x squared? 10x. What's the derivative of negative 4 secant of u?
Negative 4 secant tangent.
Negative 4 secant of u, tangent of u. Hannah has started to memorize her trigonometric derivatives. If you don't have those memorized, it's going to be a problem for you next week, Friday. So you plug in the 5x squared and multiply by the 10x. If I multiply by the 10x, I get a total of f prime of x is equal to negative 40x times the secant of, what do I place in for u? I place that 5x squared, and I place tangent of 5x squared. Are you okay with that? Those are the basics of the chain rule. Okay? Were you able to have some success with the assignment you had yesterday? At least get a few problems right.
Oh, yeah.
Okay? So let's move on to ones that are more challenging, because those are the easy examples. We want to try the tougher examples now. Okay? So this example here, number 5, I need to use the chain rule. But does anybody know what other rule I need to use in conjunction with the chain rule? Why product? I have a 2x. If it was just 2 times, I wouldn't need the product rule. But the x, that creates a new function that's different than a constant. So therefore, I have to set up f and g. What is the product rule? F prime g plus g prime f. So I have the derivative of this function is going to be equal to 2 times 4 minus x to the 4th power. Plus 2x times, now I need the derivative of 4 minus x to the 4th power. You agree? Okay, so on the side here, I'm going to go ahead and work through my chain rule.
Oh. Okay.
How do I set it up?
U to
U to
the 4th.
the 4th and
4 minus x.
4 minus x. Derivative 4 minus x, negative 1. Derivative u to the 4th, 4u cubed. So we get negative 4 times 4 minus x to the 3rd power. So does everybody agree this is going to be 2 times 4 minus x to the 4th power minus 8x times 4 minus x to the 3rd power? Lily? Matthew?
Does G prime equal 0?
G prime does not equal 0. G prime is negative 4 times 4 minus x to the 3rd power. Question?
I'm confused. I got that.
That's F prime.
Uh-huh.
That's G.
Uh-huh.
That's F.
Yep.
That's G prime.
So that little square is not for the whole problem?
That little square is just the derivative of G.
Oh.
Now, you can't leave your answer like that. I've never seen it expressed like that on the AP exam. When you use the product rule in conjunction with the chain rule, you must take out the common factor. So we're going to write this in factored form. What's the common factor between 2 and 8x? You take out a 2. What is the common factor among 4 minus x to the 4th and 4 minus x to the 3rd? So I take out 4 minus x quantity to the 3rd power, okay? So that's the common factor that I remove. What is left when you take a 2 times 4 minus x to the 3rd power? What do you have left when you take it out of that? Just a 4 minus x. And then what are you left with when you take 2 out of this? Minus 4x. Are there any terms that you can combine there? Yeah, 2 times 4 minus x quantity cubed times, looks like we have a 4 minus 5x. That's how I see the answer written on the AP exam. If you would so choose, can you multiply the 2 by 4 and negative x? No. Can you take 2 times the 4 and the 5x? Yes. So if you want to multiply the 2 through there, I'd mark that correct as well. But on the test, this must be written in factored form. I see this problem consistently in the multiple choice section of the AP exam. This is something you've got to be prepared to do, okay? So what our goal is today is yesterday you had the foundation, the chain rule. Now we want to try chain rule with slightly more complicated problems. Now, I will say you guys have this going for you, is that I've never written this test before because I'm breaking this test up into 2 parts. You see what I'm saying? To try to meet where we're at. So I'm rewriting it, and I'm going to be trying to rewrite it really based off of what we're understanding and not what we're not understanding. You know what I mean? So as hopefully we get good problems from you, okay? Number 6, I want you to look at this one, okay? We've got sine squared of 3x. Now, people get a little bit confused here. This is another classic example of rewriting the problem. Sine squared of 3x means we take sine of 3x, we take that quantity, and we square it. That's what that means. So I first need you to wrap your brain around the fact that those two are the same. Is everybody okay with those two being the same? Okay, excellent. Okay, so I'm going to set up what rule? The chain rule. Why did you say product? This is what I have to know from you guys. Why are we saying product?
I get it now. That's what we did on the last one.
Okay, got it. So you could say sine of 3x times sine of 3x. Yes, you could do the product rule in that way and you'll come up with the same answer. The easier way to go about this is to set up the chain rule. Namely, what is the outside? Don't start with the inside, start with the outside. U squared. What's the inside? Sine of 3x. Is everybody okay with that? What's the derivative of u squared? 2u. The derivative of sine of 3x, doesn't that require us to use the chain rule?
That's what I meant.
Isn't that what we practiced yesterday? Like when I told you find the sine of 3x, remember I said the difference is when you see sine of 3x, that's the chain rule. If you see sine of x times 3x, that's the product rule. See the difference? So this problem involves the chain rule, 2 times. So what I'm going to do is I'm going to set up another piece for the chain rule right here. For sine of 3x, I see that the outside is sine of u. What's the inside? 3x. Derivative of 3x? 3. Derivative of sine of u? Cosine of u. So what is the derivative when you multiply those together? 3 cosine of 3x. Good. So I put the final derivative here because that's what I was trying to find. Now I multiply those two together. 2 times 3, I have 6. What do I put in place of u? No, sine of 3x. What do I put in place? And then after that, I have my cosine of 3x as well. That's the derivative. Okay, I want to let you guys practice a little bit before we get to some other problems that are a little bit more involved. I want you to try A and B on your own. A and B on your own, okay? Try those. Those are just one-step chain rules. One-step chain rules. Go.
The same as this.
This guy? We're going to do this next week together. You don't have to do it. We'll do that together.
We can hold on. Okay. I wasn't using boxes on the other thing, but I think it'll help me find the boxes when they're coming down. Like what? Yeah, what you're, the different ones. Where they are. Yeah.
Good. Square root 2 to the 6th. So then we just multiply those two together. So that times out to give you. And then for you, you plug this back in. That's it. It's a derivative. That's how you do chain rule. Okay.
Yeah.
You're good. Hold on. Good. So, yes, either way. Good job. Good. Either the one.
Yeah, okay.
I'm gonna now work on them as you check to see how you did. Glance. We okay? Any questions?
Yeah.
Everybody good?
No, I have a question.
Yep. Last time we asked a question, we didn't actually talk, so I'm waiting for that.
I think it, would mine be correct? Because I just didn't put the 3 on the bottom. I left the fraction in the top.
So if you have negative 4 over 3 over 7 minus 4x to the 2/3 power, I would take a half a point off because you now have a complex fraction.
You don't want.
You cannot have a complex fraction ever. Yes.
On the test, so instead of doing it to the negative 2/3, I put 1. How much would you take off from that? So I originally had this as 1.
Okay, so you didn't have the third power? Yeah, that'd be a full point on. Yep. Okay, all right, so before we move on to the next piece, you guys are ready here, okay? I'm monitoring where you're at. I'm trying to help you all. I see where I need you to be. And here's one thing I want you to understand. Watch this. Suppose I'm going to put these two down. I'm going to put cosine of 5x, and I'm going to put 2x minus 8 to the 10th power. I want to find the derivative of those two, and I'm going to do it without making any boxes. You can make boxes forever. That's fine. Sometimes I do it, sometimes I won't, but I want to show how easy it is. The way we use the chain rule is we take the derivative of the inside, which is 5, times the derivative of the outside, which is negative sine, with the inside left alone. That's the chain rule. The derivative of the inside times the derivative of the outside with the inside left alone. That should make sense to you with the boxes, right? Because this is the outside, that's the inside. What do we do with these two things? We multiply them, and then we put that inside back in, right?
You're not gonna adopt this if we use the box.
No. I'm just saying that at the end of the day, I've been teaching this for a while, and 2/3 of the class, they stop using the boxes at some point. You know what I mean? I should say about 1/3 of the class stops using the boxes at some point. A lot of people like to go to that piece. Watch again. What's the derivative of the inside? 2. What's the derivative of the outside? So I've got 20 times 2x minus 8 to the 9th power. See it? Derivative of the inside times derivative of the outside with the inside left alone. That's the idea that we're using. The boxes should help keep you organized. Use the boxes the whole time if you want, 100%, okay? I just want you to know, I may use the box for that sometimes. As we move forward, I'll probably never use the boxes for that again. I think that one's pretty straight to see, you know what I mean? Just helps save me as we're doing some work. Okay, all right, so let's go back. Whoops, I'm right here, and we're gonna move to a couple other problems. I want to move problem D. Okay, we'd like to see if we could get through a couple more problems today. And then our goal is to get through this section by Monday. And then that'll be the last of your assignment. So only one more assignment for this unit, which you'll be able to start on today. Problem D, what rules? There are multiple rules here. What do you see? The chain rule and the product rule. Does everybody see that? Okay, what is the outer structure? Do you think I start by saying the chain rule, or do you think I start by saying the product rule?
The chain rule for each one.
The chain rule for each one, but they're both being multiplied together, right? So I want to look at the product rule overall, F and G. So I take F prime G plus G prime F. So I'm going to go ahead and set up just my boxes over here to take the derivative of each of those. So then I have them on hand, and then we're going to do some factoring. We're not going to do this problem. You guys know I do it super easy. So I start with u to the 5th and x plus 2. The derivative of u to the 5th, 5u to the 4th, derivative of x plus 2, 1. Okay, so it turns out that if you're doing the product rule, we have f prime g plus g prime f. So I start with 5 times x plus 2 to the 4th power. Is everybody good with that? What do I put next? 3x minus 8 to the 7th power. Good. Plus or minus? Plus. Now I need the derivative of g, don't I? And I've got u to the 7th. I've got 3x minus 8. Now, I know that some of you are already thinking about doing that without the boxes. I'm still writing them down just for our benefit so everybody can see it. So what do you get there? 21 times 3x minus 8 to the 6th power times x plus 2 to the 5th. Good job. Nice. Good work. Okay? If you have the product rule in conjunction with the chain rule, you always must write it in factored form every time. I've never seen it expressed otherwise on the AP exam. So what I do is I factor out what is the common factor among 5 and 21. Nothing. What's the common factor among x plus 2 to the 4th and x plus 2 to the 5th? So x plus 2 to the 4th is a common factor. What's the common factor among 3x minus 8 to the 7th and 3x minus 8 to the 6th? 3x minus 8 to the 6th. So I take that out. That's my common factor. And we remove that common factor. Lily, do you see that? Okay. So I'm looking at this thing right here, and I'm looking at that thing right there. They both share an x plus 2, right? They both share 4 of them. And they share a 3x minus 8. They both share 6 of them. So I'm taking that out as my common factor. Okay, it would be kind of like this, Louis. Suppose I had 4x squared y plus 6xy squared. You're taking out a 2 and an x and a y. Those are being multiplied as well, aren't they? So this is like my x, this is like my y. I'm taking them out. That's what's happening, okay? All right, so we've got that. What are you left with in the first expression? Good. 5 times 3x minus 8. What's the next symbol to come? Plus, because of this addition sign right there. Then what's left after that? I got a 21, right? Times x plus 2. So it's always going to work out that that's going to be a factor. Our x plus 2 to the 4th power and our 3x minus 8 to the 6th power. And then you're going to have this guy left right here. We're going to have some terms we can combine, right? You have how many x's here? 15. And you're going to have, that makes 36 x's. And then you're going to have a negative 40 and a positive 42. Negative 40 and a positive 42? Positive 2.
Do you have to factor out a 2 from that one?
No, you don't.
Okay.
If you want to put the 2 out in front, you can. You don't have to. You okay with that? You can see that that's algebra intensive, right? And to be clear, you would have said previous this, you would be like, algebra is like what I love, right? But you can see that algebra gets complicated, doesn't it? In college, I've seen professors that they will just show the first part, and then they'll say, and the rest is self-evident, and they'll just move on from it because they're like, you've already mastered the algebra, so we're not even going to go over it. The algebra of calculus is a little bit more involved sometimes, isn't it? And that's why we got to be careful, okay? So, okay, last example, I think, for the day, we'll do problem A here. We'll do problem A, and we'll try to leave. We'll do A and D. We'll get through A and D today. Those aren't too bad. And then on Monday, we'll polish it off and finish it up. Again, on Tuesday, you won't have an assignment. It is simply going to be a review of trigonometry day. I think that would help us. Okay, what rule?
Product and the chain rule.
The product and the chain rule. Good. You see it, that those look similar? So I have F and I have G. Away we go. F prime of X is equal to negative 6x. I like it. Times
Cosine 4.
the cosine of 4x.
Now you have to do the chain rule.
Plus, I'm going to write the negative 3x squared times, now I need the derivative of cosine of 4x. The cosine of 4x, as Addie says, requires the use of the chain rule. I'm not even going to make the boxes. What's the derivative of the inside? 4 times, what's the derivative of the outside? Negative sign, with the inside left alone. Y'all good with that? Okay. So that means that the derivative of f is equal to a negative 6x times a cosine of 4x. Is it plus or minus? It's a plus 12x squared sine of 4x Did we use the product rule in conjunction with the chain rule?
Yes.
We did. So if you did the product rule in conjunction with the chain rule, then you must take out a common factor. What is the common factor that can be taken out?
6x.
Yeah, I'm actually going to take out a negative 6x. And if you didn't take out the negative, that'll be fine. I'm just making that choice. What remains? Cosine of 4x,
Minus
2x sine of 4x. There's your derivative. Okay, we try one more for the day.
So once you take this out, let's take these two. Can't do. I got it, it's okay.
You're good?
Yeah.
Okay, I just want to honor that. Everybody, obviously, what rule would we use for letter C and for letter B? Yeah, everybody see the quotient rule is used for B and C. So you can make some of these just absolutely ridiculously difficult. I don't want to push us too hard, but we don't want to spend time on the quotient rule today. We'll do that on Monday. But, quotient rule, that works out a little bit differently, but I do want to see one or two of those. But we'll get to problem D here. Problem D is a really good example. It follows in line a little bit what we talked about so far. And when I see a trigonometric function to the fourth power, it's important for me to write it. And as I rewrite it, here's what's going to be new for you in understanding. Is the negative 8 being taken to the fourth power or not? It is not being taken to the fourth power. So if you were to rewrite this, we would have negative 8 times the sine of 4x minus 2 raised to the fourth power. That's what we have. Does anybody see the two rules that I will use here? Hint, we've seen it before. No product. Chain rule twice.
Yeah.
Okay? I see this set up as the following. Negative 8u to the fourth. What's on the inside? Sine of 4x minus 2. What's the derivative of the outside? Good. Does everybody see that to take the derivative of sine of 4x minus 2, I have to use the chain rule. So you could set up a second set of boxes, or you could just look at it. What is the derivative of the inside? 4. What's the derivative of the outside? Cosine of 4x minus 2. So we actually did the chain rule twice, okay? We didn't write out the boxes. So I'm going to multiply these. Negative 4 times 32. Negative 128 times, it looks like we have sine cubed of 4x minus 2 times cosine of 4x minus 2. That's the derivative. Just got a message from Ella Bordeaux. You guys remember Ella? She said, this is about a month ago, she said, make sure you tell your calculus class that it was week 1 in her chemistry class and they were taking derivatives. Okay? So are these applicable within your science courses? Absolutely. Okay? Do the professors go over the review? Sometimes. Sometimes maybe not. I don't know. I don't think they were taking a derivative that difficult. You know what I mean? It's probably like y is equal to 12x squared plus 8x minus 1. What's the derivative? Oh, 24x plus 8, right? Like, hopefully you'll never forget how to do that, right? Will you forget how to do that?
No.
No? Hopefully not. I better stop this before